Welcome. In our last tutorial, we saw how the scanner scans white spaces and how it checks if we are at the end of file. Now, in this tutorial, we'll scan numbers, keywords, and identifiers. So let us begin. We start by defining the isNum function. This function returns true if the current token is a number. We pass our token as argument to it to check if it is a number. It first of all converts it from char to integer by subtracting 0 from it and assigning it to an integer a. Then it checks if the value is between 0 and 9. It returns true if it's an integer, else it returns false. So in our scanner function, if the current token returns true for isNum function, then it means it's a number. Then we pass it to the generate token function to generate the token number for us. So this generate token function will check the rest of the token to know if they are also numbers and generate token numbers. For the case of multiple integers, example 200, 49, 389, 28, 389, it will check character by character to know if they are all number and then generate token number. So it will loop through our tokens and merge all of them together. Next, the first token of every keyword and identifier is an alphabet. So to check for identifier, then we have to check for alphabets. We use the isAlphabet function. We simply check if the current token is between A and Z, or between capital A and capital Z, or if it's an underscore. So these are the only characters that are used for generating keywords and identifiers. If it's an alphabet, we then call the keyword token function. Now let us define the keyword token function. Just between the scanner function and its alphabet function, we define the keyword function. It will be a static void function because it is private to the script and does not return any item. Already, the isAlphabet function, which called this function, has already found the first letter of the keyword to be an alphabet. So using a switch, we will match the first letter in the keyword function. If it matches the first letter of any keyword, then we use the check keyword function to check the rest of the keyword. Example, consider break and bool keyword, whose first letters is a B. So if the current token is a B, then the check keyword function will check for rec and ol, OOL, without their first letter B, since it has already passed the switch, since the first letter has passed the switch. So at the end of the switch case, if no keyword is matched, we generate token identifier. That is, if it does not match any of the keyword, then we assume it's an identifier. So the check keyword takes 3 arguments. The first is the characters to check for. Example, in the case of break, it will only check for REAK. 2, to also check how many characters to check. So in the case of break, it will check for only 4 characters, R, E, A, and K, since B has already matched the switch. Then 3, finally, it takes as an argument the type of token we are generating. In the case of break, the name of the token is token break. So the third token will be the type of token we are checking for. So that is the token it will generate if it is successful. The check keyword we call the make token function to generate the token if the rest of the tokens match and also returns true. When it returns true, we will now skip the generated tokens to point to the next token within our code file. So the number we increment is equivalent to the number of remaining characters of the token. Example, for break, we skip REAK, which is equivalent to 4, so that we can point to the next token. So, after the first letter of every keyword, the check keyword function checks the rest of the characters of the keyword. It is a boolean function that returns true if it's found the keyword, else it is false. So on line 84, the first thing the check keyword function does is to make sure that whatever comes after the keyword is neither an alphabet nor a number. Example, break 1, break A, break 25 does not represent the keyword break. But assuming we have break equal to, or break in parentheses, or break semicolon, it all represents the keyword. So it is going to make sure that after the keyword, the next character that comes after it is neither a number or an alphabet. So, to do this, it adds the total number of tokens to the current token and checks it on line 89. Example, for token break, the num char is equal to 4. If the first letter B is at position 0, then we add 4 plus 1 to token, so that the token becomes 5, which is the character that comes after K. The last letter of break, then we check the character at this position to make sure it's neither a number nor an alphabet. Then on line 86, we use a for loop, which loops through the rest of the token, comparing it with the actual names of the token we want to generate. If at any position they do not match, the check keyword function returns false, else it exits the loop and returns true. Then there are also special case tokens like the NL, which in C++ is equivalent to a new line. So for such a token, we are going to convert it to string and assign /n, which is also equivalent to new line. The token pin is a customized token I created for my Brain.io project on my website. So anywhere we see token pin, kindly ignore it, since it's not a standard C++ syntax. Then, if the check keyword match and everything is successful, we call the makeToken function and pass the token type, which is the third argument, as argument to the makeToken, and returns true. So the makeToken will now generate our token. And back to our keyword token function. If none of the first letter is a match, or if the first letter is a match but the rest of the tokens is not a match, then we assume it's an identifier. Therefore, we generate token identifier. Identifiers are user-defined names, while keywords are standard language-defined names. So that is a major difference. So we already know what keywords we have. So if we check and none of them is a match, that means it's a user-defined name. So as a compiler designer, it's your duty to define what keyword you need in your programming language. So now we have seen how the scanner scans for keyword and identifiers. In our next tutorial, we'll scan for symbols using the char token function.